Hello everybody, Assalamualaikum warahmatullahi wabarakatuh. We want to present our presentation about navigation layer model on maritime professional education integrated with STEM approach, analysis and design. We are from Maritime Academy of Suakabari Cirebon and I'm IING MUSTAIN as presenter in this event, and my partner Abdurrahman ATT2, Endang Iskandar ATT3 from Engineering Department Maritime Academy of Suakabahari Cirebon, and other is Captain Dedi Nuryaman, Master Mariner from Nautical Department Maritime Academy of Suakabahari Cirebon. We are presenting this in this event of first Faris Panjapa, the National Seminar on Computer Science, Engineering and Technology. We are about STEM, yes, STEM education for 21st century skill. National policy document as related to development of the future generation of STEM professional, including vocational education. Implementation of professional education refer to development student learning in vocational education in future. STEM education support for innovation in daily living according to partnership for 21st century skill. STEM in vocational education as maritime need to integrate disciplinary and promote cooperative learning in the real world. Teacher will need a new interdisciplinary content knowledge base. STEM literacy as a core component of comprehensive care and college ready has three key outcomes. First, all students develop a core foundation within a core STEM discipline so that they can be active and engaged in society that is scientifically and technologically rich, complex, and dynamic. All students develop a strong conceptual and factual knowledge within a course STEM discipline to prepare them for secondary education pathway that will lead the rewarding family wage earning career with option for growth and mobility. Third, an increasing number and the first group of students are motivated and encouraged to pursue STEM profession through a rich, robust, and relevant learning experience. Some problems faced by educators while students are studying in how to develop thinking, not for individual, but model thinking in group discussion, such as collaboration, problem solving in the context of K-16 STEM education and the workplace. Problem of the cognitive and social skills are different from traditional students in studying and individual problem solving in their learning. Vocational STEM, we use the PVL model. PVL are not a concept in science and mathematics, not new concept in the science and mathematics, and PVL prominent in national education standard. The following design principle in fact, the design of PBL are making content accessible, making thinking feasible, which include using visual element to help the learner and using learner constructed visual element to assess learning, helping students learn from others, and promoting autonomy and lifelong learning. Engineering apply concept from mathematics, design, and technology to solve complex problems is the systematic manner how the engineering cadet do in their learning. There are many variations in practice today. They need to formulate the best solution possible in the learning and the act following the same future process building problems, solving in skill and logic. They make a group of discussion and set a layout of navigation based on correct then build up the model navigation lane. In our research, we use three A. They are engagement, exploration, and extension. In engagement, the student identify problem and constraint. In the exploration, they analyze idea, communication, and discussion. And in the extension, they design the layout and build product. Navigation light, visible of navigation light as in the figure is the sample of the maritime rule based on International Maritime Organization or IMO regulation and the Colrec rule. The methodology is analysis and design. One widely used instruction model is the BSGS 5A model, which provides a structured sequence of running steps. This paper we use 3A model as table 1 summarize the step of the 3 model and tie them to step in the engineering design process. 3A step are engagement, exploration, extension. Design process step, identify problem or constraint, analyze idea, communication in step exploration, and in the extension, they design and building the product. The result, first engagement, they identify problem and constraint. First step, that student identify the present caloric accident data to find what problem was happening. When a case of collision, as the number of maritime accident is a big problem in maritime accident. The recent report is indicated that more than 80% of maritime collision accident are caused by related to human education failure concerning the lack of situation awareness and failure to comply with the convention on the regulation, international regulation for preventing collision at the sea. We see that more than 80% of maritime collision accident because of failure to comply with the COLREG regulation. Secondly, exploration, the analysis and communication and discussion. The engineering cadet student with the officer cadet student discuss in the group who analyze the role of lag and SAFE based on COLREG 1972. Both lag and SAFE as rule 2020 application. The third is the extension, design, and build. From COLREG rule that engineering cadet student with the officer's cadet student discuss in group to design the navigation model. This design take for education, the classroom teaching and learning simulation. So model of visible light taken the example from small vessel then 12 meter in length. The rules in 22 is the visibility of the light in the vessel of less than 12 meter is in the lake are mentioned masthead lake 2 mile, side lake 1 mile, strand lake 2 mile, towing lake 2 mile, white, red, green or yellow all round lake 2 mile. They built up the navigation model, student set layout of navigation as the figure that the model for like as navigation lake as we refer to International Association of in Lake Host Authorities. And after they make the layout, they build the product, the miniature of navigation as the figure. And after that, the student of process the charging and loading. The process of charging electricity starts from a solar power sold from 50 watt solar as shown in figure 3. that the charging and loading process from uh, our solar power source. Here the result. When a process charging or charging process, we see that the voltage or potential voltage from time at 9 a.m. to 11 past 30 a.m. That's increasing the voltage from 9.9 volt to 12.9 volt for charging process. And the current electricity from 9 a.m. to 11 past 30 a.m. There's increasing also from 3.70 to 4.07. That's the process charging. There's increase of number of voltage and current electricity. For the loading process, also there's increasing number of potential from 11.3 to 12.9. In time from 9:30 to 11 past 30. And the current electric also there's increasing from 3.7 to 3.86. That's the process of loading from the battery. And the last of the calculation, from integrated STEM approach with GA model in PBL teaching and learning, we investigate that student can build navigation model would consist of anchor light, mast light, towing light, and side light. The anchor light placed above the forecastle deck must headlight lamp is placed one in front of and is placed behind both of them at the ship center line. Meander model of navigation lamp with source of energy from solar cell 50 watt power and the electricity used control added for charge and load of the lamp. Both charge and load are measured with digital volt ampere meter. We obtain that engineering cadet understand of rule of Ulrich about light and shape, which can build from miniature model with PV solar cell as source energy. Announcement. We want to say that for Director of Maritime Academy Agnes Wakabahari Cirebon for supporting us in international seminar on PVJ. First is ISComSET organized by Universitas Muhammadiyah Universitas Tasikmalaya. Here we are a reference we use. And then I want to thanks for your attention, and for the end I said Assalamualaikum warahmatullahi wabarakatuh.